Alright, so in this video we're going to talk about division. We're going to talk about division where the negative sign is concerned, and we're going to start off by considering the situation where everything is positive. So if I have $15 that belongs to me, or we could say, let me say $15 that somebody paid me. Let me say somebody gave me $15. In other words, $15 coming into my coffers. Right? That would be plus 15. If that $15 comes in 5 equal payments, and I want to find the amount of each payment, I divide the 15 by 5, and then I will find that in each payment we have $3. Right? Yeah, 1, 2, 3. 15 divided by 5 is 3. If on the other hand, I want to consider the situation where the $15 coming into me, and I know that the $15 is coming into me in payments of $3 each, I might want to find out the number of payments over which that $15 is being paid to me. I divide 15 by 3, right? Because each payment is $3. So the overall payment divided by the amount of each separate payment would give the number of payments. 15 divided by 3 will give you a 5. 5 payment 1, 2, 3, 4, 5. We understand that situation intuitively because it is something that we experience all the time. On the other hand, if instead of money being paid to me, I am the one now paying the money to somebody else. Excuse me. In that case, instead of representing the 15 as plus 15, what I would do is represent the 15 as minus 15. Same 15, but it moving in the opposite direction. All right? So if I am paying this $15 in equal installments of $3 each installment is $3 leaving, right? So we could represent that as minus 3. We apply the same logic to the smaller payments that we apply to the total sum of money that we pay out, which is once it's leaving, we represent it using a minus sign. So overall payments going out divided by the amount of each payment, that will give you the number of payments. That is something that we could appreciate from a common sense standpoint. In natural language, in our speech, in our conversation, we would just say 15 divided by 3. Because the underlying context of debt is already understood. But if we deal in a mathematical context where the underlying context may not be immediately apparent, then we have to communicate that as part of the mathematical discussion. And in this case, the vehicle we use is our good friend, the minus sign. I could consider the other situation where, again, same $15 that I am paying out, and I am paying out this $15 in 5 equal payments, right? So in this case, if we want to find out the amount of each payment going out, we would divide the minus 15, which is the overall debt, look at here, all 15, divided by the number of payments, divided by the 5 payments. You divide the 15 by 5, the minus 15 by 5, sorry, and you get minus 3 as the answer. So again, in natural speech, in our regular language, we would say minus 15 divided by 5 is equal to, sorry, in natural language, we would say 15 divided by 5 is equal to 3. A debt of 15 divided by the number of payments will give you the amount of each payment. But again, if we speak in mathematically, the context may not always be apparent immediately. So we communicate that as part of the communication by saying overall debt 15 represented by minus 15 using the negative sign divided by the number of payments. That would give you the amount of each payment, which is 3, but because it is a debt going out, represented as minus 3, right? So we understand these two scenarios using money because these are things that we experience. At some point or the other, we experience people paying us money, and at some point or the other, we experience having to pay money to people, right? So these two scenarios can be used to illustrate a couple more laws where the arithmetic of the negative sign is concerned. In this case, we can say that a negative number divided by a negative number will give you a positive number. That is a law. And then in this case, we can say that a negative number divided by a positive number will give you a negative number. What about the case of a positive number now being divided by a negative number? We could consider that too. So if we consider the case of the same $15, right? And we consider the situation where the $15 would have gone out and come back. So in other words, instead of saying that when the money leave, it stay out, we're saying that when the money leave, it come back. So we know that we end up with $15, right? But as we discussed previously in the case of multiplication, in the circumstance where the money goes out and instead of staying out, it comes back, we can use the negative sign there as a reversal of the situation where the money goes out and stays out. Right? Remember, it's all about, remember, the use of the minus sign is all about meaning, and the meaning would form part of an overall context which would be understood, right? So money goes out and stays out, positive. Money goes out and returns, negative. We're counting that as a negative number of times. Same 5 times, but we use the negative sign to signify that the money goes out and comes back. Right? Once the definitions are clear at the beginning, then you just have to apply the arithmetic accordingly. So Knowing that the money returns means that we have $15. So if we have $15 in a situation where the money goes out and comes back, and we know that when the money goes out, it goes out in a wad, and each wad has $3 of money going out, right? Given that the money returns, we know that it's 5 wads, but instead of 5 we have -5, because this is a situation that tells us that the money didn't stay out, it came back. This is in contrast to the situation where the money went out and stayed out, which meant that we had -15 divided by the same $3 per wad. Sorry, the same, yes, $3 for each wad going out. It means that in this case the number of wads will be 5. 5 times if the money stay out, -5 times if the money returns. $15 negative if the money stays out. $15 positive if the money returns, right? So it's all about meaning, it's all about context. It may appear to be a little arbitrary, and to some extent we can say that it is arbitrary, but the most important thing I wanted to remember is once you are clear about the definitions, what is positive and what is negative, then the algebra would flow. And even before you get into the general rule, you would get a sense of what the situation is in terms of what is positive and what is negative. And then you could get back to the rules now, which we'll do in a little bit. So again, in a situation where the $15 went out and came back in, we have $15, right? And we know that that $15 went out 5 times. But remember that this 5 times is different to the previous situation where the money went out and stayed out. In this case, the money went out and came back. So in other words, the money ended up back in our coffers, and we use the minus sign to signify a reversal of the situation where the money went out and stayed out. Again, the concept of reversal. In that case, we want to find out the amount of each wad going out. How much money was in each wad that went out and came back? Remember, it didn't go out and stay out, it went out and come back. So in that case, we divide the $15 going out, $15 going out, by the number of installments going out. 1, 2, 3, 4, 5. Remembering, of course, that each time it goes out, it comes back. It goes out and come 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 back, and it goes out and come back. In that case, the amount of money that left in the first place is -$3 per wad. So in other words, for each of these wads, the amount of money that leave is -3, right? And this minus sign tells us that the money leave and come back 5 times. So in other words, just as we had in the case of multiplication, in one operation, in one line, so to speak, you have 2 minus signs. And both of them could mean 2 slightly different things. That is how complicated it could get. But that notwithstanding, the rules of the arithmetic would apply, and you could just apply the rules and get the answers that you would get under the mathematical rules, and the answers will be consistent with your common sense experience of whatever situation the mathematics is describing. Provided, of course, that your definitions are consistent and that your arithmetic is consistent and correct. All right? And again, we could contrast this with the previous situation where we would have had a debt of $15, right? And in that case, because the $15 went out and stayed out, this would be +5 below, not -5, leaving us with the same -3 on top here. Right? Same debt of -3. Overall debt divided by the number of times the money went out and stayed out leaves you with $3 of debt each time the money went out. $3 in each wad. So, in blue on the left side here, we have some new rules as well, which would be that, let me see, right, we could rub off this part on the right because that's what we just did. So in blue on the left, we could illustrate these as follows. These situations here represent two general rules, which is to say that if you divide a positive number by a negative number, the answer is negative, and if you divide a positive number by a negative number, well, the answer is negative, right? Okay, so I just basically repeated myself. So in other words, the rule that we illustrated here is basically one rule. I just kind of went along in terms of trying to write it both times. The rule is that a positive number divided by a negative number will give a negative number as the answer. That is the basic rule. So in other words, we can sum up all the rules on the division as follows. All right? We illustrate. Now we just write it down. Right? And the general rules are for division as follows. We start off as we did in the case of multiplication. We start with the familiar, and we say that positive divided by positive is equal to positive. We know that. We're sure about that. Right? And then we come down into the new thing now. This is the new area that we're getting into, the negative sign. All right? We said that negative divided by positive will give you negative. We said at the end there, right, let us go in order now, that positive, we had two versions of that, divided by negative is equal to negative. And we also said that negative divided by negative will give you positive. All right? So we can partition these rules. Bam. So just as was the case in multiplication, you have 4 combinations of positive and negative if you're dealing with two entities interacting with each other across the operation of division. And just as was the case with multiplication, this particular video also includes exercises to practice in division. For each one of these rules, we have exercises to practice. Positive, but what madness I write here? This is supposed to be positive. I am sure I said positive, but, right? Right. Right? Positive divided by positive is equal to positive. We have an exercise for that. That is just a revision of your tables. So you have your multiplication tables, which can also be expressed as division. So if 5 by 3 is 15, 3 by 5 is 15. We could practice that as division by saying 15 divided by 5 is 3, or 15 divided by 3 is 5. That's this guy here. Everything positive. We have an exercise for this. Negative divided by positive is negative. We have an exercise for this. Positive divided by negative is negative. And we have an exercise for this. Negative divided by negative is positive. You have an exercise for each scenario. You have the opportunity to practice. So above and beyond enjoying the video or liking the video, and as an extension of understanding what was presented in the video, you now have an opportunity to cement the understanding by practice. And I want to encourage you to not forsake the practice, even if you understand it. Right? By practicing it, you put yourself in a position to execute it in a pressurized situation, which could be an exam or otherwise. Right? So as much practice as you need, the exercises are there, but I trust that my attempts to explain and to illustrate the arithmetic of negative numbers using our good friend money, the ubiquitous money. Hopefully we're making some progress in terms of understanding that, all right, using money, we construct the situations, we define the thing, we realize that certain things happening, and we could tie that back into the mathematical rules that people will just normally tell us and expect us to take it and run it, which you may have to do to some extent, but we are trying our best here to clarify the thing and to illustrate the thing.